Let's face it, concurrent programming can be error prone. It's difficult to get right. It's really easy to miss some edge cases. And when you think you've gotten it right, somebody's probably going to test it and find an issue with your code. In modern versions of Java, like JDK 21, they're trying to help us programmers by introducing something called structured concurrency, which allows us to put like tasks together. Think of it as a way to better streamline concurrent programming and make sure that you have things like error handling much more under control and automated for you. Up here is JEP, or JDK Enhancement Proposal number 453, where structured concurrency is now a preview feature in JDK 21. It was an incubator in JDKs 19 and 20, and now it's a full-on preview feature, so hopefully it's going to be part of the language in a later version of the JDK. This JEP is a good read if you want to get an overview of the structured concurrency feature, but a quick little summary right here is pretty good. Simplifying concurrent programming by introducing an API for structured concurrency. So they're giving us a new API, and a similar API that has been in use in the past is the executor service that was introduced in JDK 5. And we'll talk about the difference between the old JDK 5 way and now the JDK 21 way. And basically, structured concurrency treats groups of related tasks running in different threads as a single unit of work. So think of that as a really important feature of what structured concurrency brings for you. Current concurrency models are really big on just submit a task or a callable and then give me the result when you have it in the future. Whereas structured concurrency likes to structure all of those like tasks and make sure that the end result happens in the way that the developer expects. So now that you know a little bit about the structured concurrency feature, let's get some examples together in IntelliJ and really dig into it. Alright, so I have a fair amount of code written here, and the first thing you'll notice is that I do have the JDK 21 preview features turned on because I'm able to compile this code with the instance main method here. If you need a reminder on some of the JDK 21 features like instance main methods or virtual threads, I'd recommend you check out some of my earlier videos on those because it's important to generally follow what those are in order to follow the example here. So to explain what the code is doing, we have a try with resources here for the executor service, and the executor service is going to create a virtual thread for each task that gets submitted. So since this is a try with resources, when we're at the end here, the executor service now implements the auto-closable interface. So the close method gets called here at the bottom, which for executor service is going to shut down the executor service, and then it's going to await termination. It's not going to call shutdown now, and we'll get into that here in a little bit. So here we go, and we submit a few tasks, and then we're collecting the result of the submit method, which turns into, these are futures. So a future is basically, I want to get the result of this future operation, whatever this task returns, and then I want to get it later when it completes. So what I'm doing is I'm getting the current time, I get the first task result, and the get method is a blocking call with future. And then I block until the second thread is complete. Then I take a look at how long it took to run the code. And this last line here, again, is something newer in JDK 21. This is a string template, which prints out the results of our tasks here, as well as the time it took to run it. And then our two tasks are really simple. The first one waits for 2 seconds, then returns the string hello. The second one sleeps for 5 seconds, and then returns the string world. Okay, so what I would expect for this to do is we're gonna wait right about 2 seconds, and we're gonna get the hello string. Then we're gonna wait about 3 more seconds and get the world string, and then we're gonna print hello world, and it's gonna take about 5 seconds. Let's go ahead and run that and confirm it's what it's doing. All right, so waiting on result. Got the first one. And then we see that we've got hello world here, and that this took 5.0169 seconds. So you might be wondering, well, what's wrong with this code, Will? It seems to be working fine. Well, it is right now, but there are multiple things that could go wrong with this code. For example, let's say that task 1, instead of returning successfully, let's say that it errors out. So let's say throw new runtime exception. So now what's going to happen is we're going to sleep for 2 seconds, and then we're going to throw an exception. And then task 2 is still going to be running, and I'm going to show that here in a second. So what we'd expect is that waiting on result is going to print, and then we're going to wait to get task 1, and then we're going to see what happens after that. So let's run the code and see. So I don't have any prints to back this up, and you know what, I'm even going to change the code just to show the real problem here. Instead of waiting for 5 seconds, I'm going to wait for 50 seconds. What this should do is as soon as my thread here throws an exception, I would want to bail out and I would want to leave the whole block here. But we're going to see with this code that that doesn't happen, even though you think it would. When the get method on the future gets called, you would think that that would throw an exception, and then that would propagate out, and then you would leave the block. But that's not what happens. If I rerun it, all right, I'm waiting on a result. Where's my result? I was supposed to throw an exception after only 2 seconds, yet now my application is hung. Or maybe this is a server and now I am hung. Ugh, ouch, this is not good. I am still waiting and nothing is happening, so what's going on? Okay, let's find out. So it is true, the get method on the future will throw an exception, but then think about what happens next. The exception is going to get propagated to the end of the try with resources block, and then the close method of the executor service is going to get called. And the close method is going to call shutdown and await termination. If you look at the source code for those things, what they do is they don't interrupt the threads, they let them finish. So that's nice in the way that you don't have any orphaned tasks or any sort of what we call leaked threads when we leave this. But what it does mean is that you have to wait for the longest task to finish, even though you already know that your overall result is failure. Why should I have to wait so long? And think about an even worse case where let's say that task 1 and task 2 are talking to each other, and let's say that task 2 had to wait for a result on task 1. Let's say that it was like returning a partial computation or something. And then task 2 infinitely waits until task 1 sends it something. Well, that's what we call a deadlock. Because now when we get to here, the executor is still waiting for task 2 to finish, and task 2 is waiting for something from task 1. Not good. So how do we fix this? Let's move to the structured concurrency model that JDK 21 gives us. We're going to use the StructuredTaskScope class, and we're going to use a particular subclass of it that basically short circuits when any of the tasks fail. So think of that. When any of my tasks fail, if I need all of them to succeed, then I want to bail out as soon as I know that any of them are failing, and I have an API to do that. So instead of calling this executor, I'm going to call this scope now. And then let's create a new instance of StructuredTaskScope. Except I don't need to use the generic, and I want to use a shutdown on failure. And then instead of the submit method, I need to use the fork method. And then I don't need this import anymore. And now instead of the get methods, I want to do something a little bit different here. The fork method here now returns a subtask object, which is new as of JDK 21. And what I want to do here is I want to do scope.join, which means that I'm going to wait for everything within my structured task scope to join. And if there are any issues, I want to throw if there are any failures encountered. Cool. So now I know that as soon as I have gone past this line of code, I can get the results of task 1 and task 2 immediately. So in here, I can do task1.get, and then I can do task2.get. And now the get methods are not going to block or anything because they don't need to. The get methods already are going to have a value in them because I already know that they are completed because the join method completed here. So let's go ahead and run this code and see how it behaves differently. All right, so I didn't have to wait the full time for task 1 and 2 to finish. As soon as task 1 bailed, I got this. I got an execution exception, which was caused by this runtime exception here. We can see that a virtual thread, again, that's one little interesting detail. Structured task scopes, when they fork tasks, they're automatically using virtual threads, which in my opinion is a good thing to be doing. We can see here when we have this runtime exception, the structured task scope throw if failed, then comes up here and throws this execution exception. And we leave, and we don't need to worry about waiting until the other tasks are completed. And we don't have the problem of any orphaned tasks or of leaked threads, because as soon as we leave the scope, all of the tasks that were submitted get closed down via interruptions. So as long as your task is susceptible to being interrupted, then you're going to be able to shut down properly. So one other really cool thing you can do is, let's say you have a hierarchy of tasks. So you've got one scope here that needs to break down a problem into 2 or 3 sections. And then let's say that section 2 is really complicated and you want to break it down into even smaller subsections. You can then break down task 2 into multiple different forks, all via its own scope. And then what would happen is if subtasks 1 or 3 failed, then you would be closing down not only subtasks 1, 2, and 3, but you'd also be closing down 2A, B, and C. Or let's say that 2C fails and you want to bail out if only one of them fails, then you're going to close 1, 2A, 2B, and 3. It's really nice. You can essentially have all of this handled for you, and this API is really straightforward to use. There really isn't all that big of a downside. Probably the biggest thing here to think about is that you have to make sure that your tasks can be exited in some clean way, such as being interrupted or something like that. That's the one thing that the language designers did not necessarily address with structured concurrency, but if you read the JEP, there's a quick little note about how they're going to consider an improvement for that in the future. Let's say that you're trying to solve a different problem, and instead of failing if any of the tasks fail, you want to succeed as soon as any of them succeed. Let's say that you're like doing a race where you're trying to see which task can complete first. And then once you know one is complete, then you're ready to short circuit the other ones and cancel them. Again, the old method where you have to wait on futures is a little ugly. You could check if the future were ready for each of these in a tight loop, and then as soon as one of them's ready, you could exit out and you could cancel the others, but that code can be error prone, and that's a lot more code than you really need. Instead, you can use the same concept here. And in this case, you want to do shutdown on success. And then I'm going to give this a string here. And then the throw if failed method doesn't exist here. Instead, the result method does, which returns the result that was given to us first. So now we can print out results. And we don't need to hold on to task 1 and 2 anymore. And this time we'll see that we return the first one that succeeded, which in this case was task 2 because it returned world, and it took us about 5 seconds. The first task failed and threw this exception, but in this case we didn't care about that because we only wanted to look at the one that succeeded. So in this case, shutdown on success. So as soon as we had a successful task, we return, we take a look at it, and we're good to go. So the 2 provided subclasses of StructuredTaskScope that allow for you to define what the shutdown policy are shutdown on failure and shutdown on success. Those are probably going to be the main 2 that you need for most situations, but the API is open to extension. If you wanted to subclass a structured task scope and have a different shutdown policy, then you can do that. For example, let's say that you had a situation where you always submitted 10 tasks, but you only needed half of them to exceed, so 5 in that case. You could write a subclass that would have a shutdown policy that enforced that 5 of those subtasks successfully complete. And one other thing that I find really cool about structured task scopes is that when you want to debug thread dumps, there are ways you can do that via IDEs or via the command line. You can get a thread dump of every single thread and you can look at the stack trace and such. The problem with the executor service threads is you had no way to link those thread dumps with the executor that submitted them. Whereas with a structured task scope, there's a way that you can look at the thread dump and you can say whose parent or whose child this is. So when you're looking at a thread dump and you're trying to debug something, now you have a way to easily trace through the threads and you can take a look and figure out what your tasks are doing. And that was an overview of the structured concurrency preview feature in JDK 21. If you enjoyed this video, please do smash that like button. I'd really appreciate it. Thank you for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.